Hey everybody, my name is Alex with Hake Hardware, and in this video we're going to go over how to get an autonomous node deployed using Linux and Docker. So to get started here, just a quick note, I'm doing this for all my videos, so it's probably going to get annoying if you're going through all of them, but these guides, the videos at least, are created for Autonomous Gemini 3H, which is a testnet. Mainnet is about to get launched. The guides, which will be, or the wiki, which I call it, will be linked in the description of the video. That should stay updated. I'll try and get these guides updated as quickly as possible after mainnet is launched. So you could still use those, but just keep in mind some steps in this video may change or may not be the same. And as always, there's an official wiki here. So if we click that and open it up, we can see as far as hardware goes, you're going to need for system requirements 4 cores, 8 gigs RAM, and 100 gigabytes at least for node storage. And you'll see for node storage, we could either store that on the host disk, or if there's a secondary disk that you want to store it on, that can be specified in the Docker container. So just go through the system requirements, make sure. One other thing is like internet speed. You want to have something pretty decent. I don't think there is a specific speed that you need, but I'd say like 100 megabits per second is probably the minimum, at least to be able to sync and have like a performant network. And then you're going to use a lot of data. There's just a lot of downloading of blockchain data. So if you have an unlimited internet plan as far as data goes, that's also really recommended. Another requirement here is port forwarding. So you're going to need to forward ports 30333 and 3433 to your node. So whatever PC is running that, you should forward the ports to that IP address. And then you can use the ugetSignal website, which is linked here, to confirm that your ports are forwarded correctly. This is, in the past, I've been like, it's not a big deal. But it really is a big deal for your node in order to get enough peers and to be able to sync with the network appropriately. I'm sure there's like more reasons, but I have noticed a pretty big difference as far as performance when I have my ports forwarded correctly. And then for system readiness, so this is basically what you should have already running on your computer if you want to get this done. Of course, you should be on Linux, and then there is a Docker install guide here if you don't have Docker already. And then there is a Portainer guide if you don't have Portainer. Portainer is optional. You'll just have to modify it if you're using a different graphical user interface for Docker, or if you're just using the Docker CLI with like a Docker Compose file. If you're using those things, you probably understand how to use those, but I'll be using Portainer. So if you're new to Docker and you're just following this guide, I recommend following my other guide here on how to get Portainer installed. But let's move on to storing the node data. So I mentioned earlier, according to the current guidelines, you need 100 gigabytes for your node, recommended 256 gigabytes. Check that link to the official wiki for the latest. But there are two options. You can store it as a volume in Docker, so it's like a named volume that you create in Docker with the Docker container, or you can specify a specific location and basically do what's called a bind mount, where you're actually mounting a folder on your operating system to your Docker container. So just keep that in mind. We'll cover that in a moment. All right, jumping into the steps here. So I'm actually going to jump over to Termius, which is the SSH manager that I'm using, and we're going to be in Bob today, and I'm just going to be following the wiki, and it'll be linked in the description of the video. And I'm going to copy and paste a lot of the commands. I typically like to type them out because I think it's just easier to follow if I do that. But some of them are kind of long and tedious, and it's really nice to be able to copy and paste. I mean, half the reason why I create these guides is so that I can use them and then just copy and paste them every time I need to set up something. So I've Docker installed, and the first thing I want to do is create an autonomous network. So in Docker, you can create lots of different networks. They're virtual networks. I like to create a specific dedicated network to Autonomous, and it's mostly just an organization thing, and it reduces the chance of like port conflicts. So it's not required if you change this step or decide not to use it, just know that like all my other guides use this autonomous network, and you'll have to modify the commands and the different stack files to reference whatever you're using. So if you want to just follow the guide, my recommendation is to create this autonomous network. And it's super easy. It's just one command here. We're basically doing sudo docker network create. The driver type is bridge. Our subnet's going to be 172.25.0.0. So all of our containers will be deployed with an IP address similar to this. We'll change this last octet here to different numbers. I use a standardized IP format, so like all of my Docker containers, like if I'm running lots, we haven't gotten into clusters and you may not know about it yet if you're just at the node installation point, but when you get into clusters, you could have lots of farmers, lots of plotters, lots of different things happening on the network. So each PC that you have might have Docker installed and you're going to have Docker containers deployed, and all of them will use the standardized IP address. So it's just really easy to copy and paste commands. It's a great way to organize things by creating a specific network and using specific IP addresses that you know are going to be available on that network. Anyways, let's just proceed. I don't need to sell you too hard on this. Do whatever you want, but this is how I do it. Okay, so the autonomous network is created here. And ironically, I gave you that spiel about how I'm going to be in the terminal, but this is actually all you need to do from the command line interface. And you can even do this from Portainer, but it's so much easier to just paste this command in. But let's jump back to the browser. We just did this step. I don't know why I did sudo twice in this image that I am displaying in here, but I'm going to leave it. Now we're going to go to the stack file. So we're going to jump into Portainer here. And I'm going to jump into Bob. And we have one stack file. This is just for monitoring my GPU. What we're going to want to do is create a new stack file. So add stack, and I'm going to call it, I always deploy, so you can have a node and a farmer and all sorts of things on the same PC. That's totally fine. I like to divide my stack files up a little bit. You can technically put everything in a single stack file. That's what's cool about a stack file is you can do infrastructure as code where you define all of your containers for Autonomous in a single stack file and deploy it. It's a personal thing. I like to do my node separately because the node is kind of like a different aspect of your autonomous system that you're going to be deploying. It just needs to always be on, it should always be running, and like lots of things can connect to it. It just sits off to the side basically. So I like to create a stack file, just autonomous node, and then when I run my farmers and my clusters, I create a separate stack file for those because I'm constantly changing those. They constantly have to be like updated. And yes, you can do that with a single stack file, but for a readability and organization perspective and just reducing the chance of me accidentally messing something up on my node, I like to keep it separate. Okay, and then following the guide here, one thing that I do is I have created a GitHub with lots of different Docker YAML files, and I need to organize it a little bit better, but instead of putting the code on this wiki and having to update it, I'm just using this GitHub repository called Autonomous Files, and you can see I have a whole bunch in here, like when you're doing NATs, or if you want to do NATs clusters or GPU plotters. I need to organize this a little bit better. So this will probably change in the future, but I'll update the link to it. But here I have basically the node stack file that I use. So I'm just going to hit this copy file button up here. I'm going to go back and I'm just going to paste it in. And there's a few things we're going to need to update. So first is we need to update this latest version. So I intentionally do this so you don't accidentally deploy an old version. It's super easy. You come back to the wiki, and somewhere in here, right here, there's a link. We can click that, and we're going to see all the different versions that have been deployed. We want the latest one, so just copy the name here, and then you'll go down to your stack file and just paste this here. Now, if you're using Arch or like a um, what is it? Like an ARM CPU, you might need like the dash AA Arch 64 at the end here. But if you're just doing like a normal CPU, I guess I shouldn't say normal. There's like tons of ARM computers out there, but and then if you are using ARM like the Arch 64, you should on comment this so that it deploys as a Linux AMD container, or else you're gonna have some issues. And then for our volume here, and I go over this like at the bottom here, this node data section. So even though it's like part of this stack file, I cover it at the bottom, but I'm just going to go down and I might even modify the wiki. It might look a little bit different to flow a little bit better. But this is where we're doing that volume. So at the bottom, we specify a volume, node data, and then we're mounting that node data volume inside the container to /var/subspace. And then we can see our base path down here, var subspace. So we've created this volume. It kind of just exists in Docker. It's not like a folder on your host operating system. But if you wanted to, like let's say I wanted to create a node folder in my home directory, I could do home, Hake hardware, node. And now on my operating system, in my home folder for Hake hardware, I have a node folder that I would have had to create, and now I'm bind mounting it to var subspace. So files and things that get created inside here will get created in this node directory. And then if you do that, you should delete out. You no longer need this volume. So just keep that in mind. I prefer, because it's just 100 gigabytes to maybe 200 gigabytes, um, I just leave it as my host operating system because this has like a terabyte hard drive, so a couple hundred gigabytes for my Linux system, which I don't really use that much space. It's fine for me, but do what makes the most sense for you. You could even do, if you have a second SSD that you have installed, you could point to that mount point for that second SSD. Next, we get into ports. So this is why you need to forward those ports, 30333 and 3433. If you run two nodes for some crazy reason, I know some people run Space Acres and they run like a Linux system or something. You don't want two computers on the same ports like this because you need to forward those ports and you can only pick one IP address to forward those ports to. So you can update these. Like a lot of people will just do like a one-up number, so 30334 and 3334. I prefer to change um, both sides, but I guess you could only change one side, like the host operating system facing side, but I think it's best to just change both, and then you would just, update this one as well. Oop, not that high though. Oh my gosh. But I'm going to leave these the same, and then 9944, this port is exposed in the Docker container because this is what your farmer or your cluster controller will connect to, and you'll see that in the farmer guides where you're going to be putting the IP address of the node and then port 9944. Now 9080, this is going to be set for the Prometheus listen on, and this is where your metrics are going to be uh, accessible on. So if you follow the Grafana guide to monitor your node, you're going to be specifying in Prometheus to listen on port 9080. So if you're not doing any sort of metrics, you don't care about monitoring, you can delete the Prometheus listen on and you can delete the 9080 up here. And then what we're going to need to do is just update the name section. So I'll do Hake hardware tutorial. Now you can put whatever you want here basically. And then here's where we specify that we are deploying on the Autonomys network. We're going to be using this IP address, and I always use 100 for nodes, and then the other containers will be like 101, 102, 103. So it's just a good way of keeping things organized and making sure I can just copy and paste different containers to different computers and everything just works as expected. The spaceport name label, this is specific to if you're running spaceport. That's like a custom application that I created to monitor my nodes that I made available for everybody. It's not totally done, but it still kind of works. you can update this to like Hake hardware node, and then in spaceport, it's going to import this name and label it as Hake hardware node. It's just a lot easier sometimes because I name all my containers autonomous node, and if you don't put a label, then like if I have 3 nodes, which I don't, but if I did have 3 nodes, they would all be labeled autonomous node, and I wouldn't know which one is which. So like a lot of times I'll use the host name for the computer, so like Bob node, and then put in your time zone. So for me, it would be America, Phoenix. Actually, I think I have to specify. I need to update this because I think it's supposed to be time zone. Maybe time zone. Yeah, that shouldn't be like that. Let me go to the farmer. Oh, TZ equals. So I need to update that. Notice a little bug there. Okay, so we'll do that. Oh yeah, that's a environmental variable, so that makes sense that it would be like that. And then everything else you can leave the same. So we're importing this autonomous network. Because we don't define the network inside this stack file, we need to say that it's an external network that's already been created, and it's going to be called, or it's called autonomous network. And from here, we can just deploy this. So everything should be good. I like to just double check. I mean, worst case, if you go to deploy it and it doesn't work, then you just fix it. It's typically nothing's ever like horrible. Okay, it's starting. We can go, okay, so I did that kind of quick, but in your stacks, you can find your autonomous node, click that, and then down here in containers, you can see the container that you just deployed, and there's a little page icon. If you click that, these are the logs for your node. So if you were using the advanced CLI before, this is basically like what you would see in the advanced CLI. And a few things we got going on here, and this is described in the wiki, but basically we're syncing. The 0.0 BPS is blocks per second, I think. So right now we're not really syncing any blocks. Target, that's the block height, the current block height. So we need to get our node synced to this block height, and best is what our current block height is, so 0. Finalized and the like up and down doesn't really matter. Almost everybody gets this error, which is technically a warn. It's not a big deal. You can just ignore it. You might get a few like warns or something. As long as these logs keep getting produced and you're getting peers, you're in good shape. It does take about an hour now to sync, but there's something called snap sync, and it's actually shown in here. If we scroll down, uh, there'll be a moment where you get this massive like sync event, and you'll jump from like 0 to 3.5 million here, like in a couple seconds. So, and you can see I only have 6 peers at this point. This should get up to 40 if my ports are forwarded correctly, which they are not for this example. So I'm probably not going to get too many peers. But after like an hour or so, you should be getting close to 40 peers. Now keep in mind, for those that are following this guide in testnet, right now it's kind of like weird. The network is not working great because it's not incentivized anymore. So a lot of people have dropped off the network waiting for mainnet, and they're all going to rejoin for mainnet. So right now the network's kind of like spotty, but it still works well enough. I've been able to get everything to work correctly. And that's it. So the node at this point is deployed, and you can, go anywhere and it's going to stay, deployed. So if I could go to my stacks, or if I just want to see all my containers, I can see I've got the autonomous node container going, my GPU monitoring going, and then my Portainer agent, which allows this computer to connect to this Portainer instance. And it's just going to keep running. So you can go in there and just check it periodically. You can filter on it for like warn events or error, which I technically don't have an error, but it's in there, so it's kind of annoying. And that's it. Yeah, so Docker I think is probably the best way to deploy a node. And for like even mainnet, I think it's going to be the best. And when you start deploying like your farmers, and if you run a cluster, it all just works really well. You can import your GPU into Docker so you can actually use GPU plotting. I haven't noticed any sort of performance difference. In fact, running on Linux, and Docker, I've just gotten way better performance than like Space Acres. That probably won't be the case for mainnet. I think the team will probably try and get all of the different ways of running it to be about the same performance. But if you're worried about performance or you're worried about GPU plotting, it really shouldn't be an issue with Docker. You can easily import all of those, and I do have guides on how to do that, or I will have guides if I don't have them out yet. They're coming. As you can see, like in this section, we're gonna have a lot. These aren't all done, like Spaceport. It's to do. I haven't done it yet. Space Acres, I don't have it done yet. But I'm working through the nodes. Like I got, if you want to do node for the CLI on Linux, I've got a video up for that as well as the guide. Same for node with Windows CLI, and then now we're working on the node Docker for Linux, and then there'll be a node Docker desktop for Windows. So anyways, I'm rambling. Thank you for watching. Leave a like if this was helpful, and I'll see you in the next one.